Sir, we are live, sir. Please start, sir.
Okay, thank you. Yeah. Good evening, good afternoon, good morning, everyone, whichever location you joined from. This is Dr. Prakash Goteti from Tech Mahindra. I'm working as principal consultant in AI and automation areas. And I would like to thank IIT Madras and NPTEL for giving me this opportunity to share some of my views and experiences. This is purely on my own experiences, right? So I would be discussing few aspects on how one can build a successful career in the discipline, so-called data science, AI, ML, right? Big data, all these areas. So this session is planned in the following way. I will be discussing initially a couple of minutes on data types and characteristics of data. After that, I touch upon big data and analytics ecosystem. After that, we'll be looking into AML and data science ecosystem. After that, considering all these areas, we'll be focusing on prominent roles in this space, along with key competencies and the skills that one can acquire to be successful and to get opportunities in this area, right? After that, I will suggest some capability development roadmap, which might be helpful to particularly freshers and also in general and uh, even experienced professionals, right? So most importantly, last that but not the least, I will touch upon importance of learning coding, key aspects of consideration when it comes to coding, right? So first, let us look at data types and characteristics. So we know that, right? Data can be categorized into three types: structured data and semi-structured data, unstructured data. One should not have the notion of data types that we normally see in the areas like programming languages where we have integer, float, and such kind of data types, right? Here, predominantly, we are looking at data in terms of the representation and usage, right? So we have three categories: structured data, semi-structured data, and unstructured data. And let us understand each of them. Structured data means basically you have data in the tabular representation. And the tabular representation means we have rows and columns, right? And we and next level we try to put certain constraints on that, and we put primary key constraints, foreign key constraints, and essentially you develop a relational model on top of it, right? So the relational models are languages such as structured SQL and MySQL, right? These kind of languages support performing efficient operations on this particular data in terms of extracting the information retrieval from such kind of tabular representation. That is all about structured data in brief. Uh, and one important point we understand here that in order to fetch or retrieve information from this kind of storage representation, we need to know languages such as SQL, right? Now, second thing is semi-structured data. Semi-structured data has partial representation in terms of columns, but not strictly columns, but they are through annotated through markers. Like if you see XML, extensible markup language, where you annotate with tags, right? Each tag has some meaning. And similarly, JSON files. Look at JSON files. These are also have some kind of a structural representation, but the type information is missing. We don't clearly infer what the data type of a particular tag value, right? So the type information is missing. Partial structures are embedded and they are textually annotated through some kind of meaningful representation. So another example is some kind of a graph related data, some hierarchical data and stuff like that. But predominantly, when we deal with large volumes of data, you essentially look at as XML file or JSON file, right? Next comes unstructured data. These are the most familiar data nowadays because 80% of the data which is getting generated is more of this nature, unstructured data. Unstructured data in the sense that it neither has a structural or representation, and it is difficult to actually construct a kind of storage mechanism for efficient retrieval. So examples are video files, audio files, and some kind of server logs, right? Such kind of examples you can look at in terms of unstructured data. Right. On the right hand side, you can see 5 characteristics of big data, right? Because our basic context in with which we are starting is data discipline. So when I say data discipline, it encompasses through data science and uh, big data and all these areas. So considering big data as main theme, if you look at there are 5 important characteristics associated with data in the big data perspective. The first one is volume. Volume refers to the size of the data, like for example, GB, TB, so on, so forth, right? So volumes of data is getting generated. If you look at just simple mobile data, you can see volume of data that is getting generated as a function of time, right? In several, if you take few hours, you can see a lot of data getting generated. Similarly, if you look at social platforms such as Twitter or Facebook, a lot of data is getting generated depending upon the popularity of that particular tweet, right? So this is about volume. Next one is velocity. Velocity refers to the speed at which the data is coming in. That means you're looking at large volume of data which is coming at a very faster rate. Like for example, data generated by from the IoT devices, for example, and data from sensors, right? These are all typical examples of velocity. The third important characteristic is variety. Various forms of data, like for example, structured data, unstructured, semi-structured. These are all various forms of data that you actually need to deal with in this particular discipline. Then veracity. Veracity refers to authenticity or quality of data that is coming in. You know that the data is coming from various sources, right? And it is, we don't have any control, right? It is, if it is coming from some kind of database system, then your integrity constraints, whether it is referential integrity constraints or domain constraints, will help us to to deal with some kind of consistency issues. But in this case, we don't have restrict ourselves to a particular format since data is coming from various sources. Uh, Authenticity of the data or quality of the data is very important, right? Like for example, there could be some kind of missing elements in the data. It might be inaccurate, most importantly, and it might not actually provide insights, quality, quality in terms of the kind of insights that we actually generate out of all these exercise. That is veracity. Value. At the end, when we do all this, when you deal with all these tasks that you perform, right? We often call them workloads. When you perform all these workloads, essentially we need to derive some kind of a value, business value. So value refers to the outcome of this whole exercise. That means what kind of business value that the particular the data at hand can provide. So far we touched upon data types and characteristics of data, and next item is big data and analytics ecosystem. Let us understand that. You see, this is basically a data pipeline, right? You must actually see in literature also there might be some back arrows. So I prefer not to put these back arrows in the sense that I will explain the reasons for that. When you look at this data pipeline, there are important stages. How do we understand these stages, right? One way you can understand these stages is uh, by looking at individual steps in the life cycle, correct? Individual steps in the sense that, like for example, you know, software development life cycle, right? So if you are looking at software development life cycle, essentially what we have is various pages, right? Like for example, uh, data collection and design of your requirements, use case development, design, detailed design, coding, testing, and all that. So similar to that, in data discipline also, you have such kind of ecosystem. Okay, that's what we are referring to here. Yeah. Let us look at each of these stages. Data ingestion, essentially, you have data source. From data source, you actually extract the data and uh, use the data for next level of next set of stages. What are the stages we have? Data ingestion, data storage, analytics, and downstream applications, right? So typically these are the stages. Sometimes in literature you must be seeing in place of data storage you see message queue, right? Especially streaming applications. But more or less this is the sequence. So you extract the data from various sources, and essentially we have a mechanisms to store the data for subsequent processing. So after that you have analytics tier. In analytics tier, what you essentially do is you perform some kind of analytics. You perform, uh, uh, you do some kind of task that can actually give insights. So, what kind of insights that you can generate? There are four types of analytics that we do: descriptive, diagnostic analytics, predictive analytics, and prescriptive analytics. So, let us understand each of them. The first thing that we look at is descriptive analytics. Descriptive analytics has an intent of what exactly happened. So this is where you do a lot of visualizations, right? Like you construct a lot of charts like bar graph, pie chart, histogram, and things like that. And to understand what exactly it gives. Like for example, if you are looking at sales data, it might be how much sales happened in the last few months, right? How many sales happened in the last 2 quarters, and things like for example, what is the productivity, right? And it can also connected with some kind of reporting, like what you must have taken some decisions and you want to see the impact, right? Overall reduction in bugs, for example, so on and so forth. So let us look at second aspect, that is diagnostic analytics. So in diagnostic analytics, we actually deal with workloads or tasks that are concerned with an important intent that why this particular change happened. Like for example, why the share price has gone down in last few weeks. For example, why the company's sales decreases in the previous quarter, and why there is churn in customer segment, a particular segment of customers, things like why it particular thing happened is something that you normally address in diagnostic analysis, right? So in in descriptive and diagnostic, in these cases, you potentially use some kind of statistical techniques I don't want to throw away some words like, for example, hypothesis testing and p-value and all that. But essentially, if you are from statistics background, you may come up with better quality in these kind of descriptive analytics. And now let us look at predictive analytics. So predictive analytics means what is likely to happen. That means you must have seen what exactly happened, why it happened. Now basically we are looking at what might happen, what is likely to happen. You predict something. This is where machine learning algorithms, comes into picture. That's why machine learning plays very important role when it comes to predictive analytics. Uh, and there is something called prescriptive. Prescriptive is the last one, but not the least one, in the sense that it requires knowledge construction from all the three areas of descriptive, diagnostic, and predictive, right? So you infer, you prescribe certain uh, decisions connected with your insights that you got through various analytics that you perform. So decision making is something you may want to focus on. That's where you actually look at prescriptive analytics. Prescriptive analytics will be with the intent that what should be done. Okay, that will be the intent behind prescriptive analytics. Uh, this is this is basically keeping various insights that you actually got from descriptive, diagnostic, and predictive analytics areas. Okay. Now, once you perform these analytics, after that, you either persist and you actually delegate to the downstream. Downstream, in the sense that there may be some consumers of this particular processed data. There could be downstream additional applications, right? Now, I want to explain a couple of things here in this, you know, data streaming, right? First thing is, when you develop some insights through your analytics, you may want to persist right away, or you may want to persist after some point of time, right? That's why explicit storage mechanism is not actually drawn in this diagram when I constructed this. Normally, if you look at the literature, you might see some kind of long-term storage and all that, which is optional here in such applications. Sorry. The data storage that we refer in this diagram is a kind of message queue mechanism, in the sense that when data is getting generated, right? It might be having two important things. One is that it might be coming at with a particular rate and particular pace. So the analytics tier, or the analytics engine that is actually processing the data may not be having same speed, right? So there is kind of impedance matching, right? It is not exactly impedance matching. In electrical circuits we see this, right? But this is like basically mismatch of the processing rate, the rate at which data is coming in and the rate at which your application is, your analytics is actually processing. To negotiate that, potentially you might use some kind of storage like this. Suppose if you process the data at the end of every day, you generate insights at the end of every day, then essentially what happens, you don't really worry about at what rate your data is coming in, right? Because it is not in the same scale in which you are operating. In that case, what happens, you need long-term storage, right? So you need substantial storage to deal with such kind of scenarios, right? Now let us look at various tools in this particular ecosystem. Now, if you look at, we have created multiple slices, right? One is data ingestion layer, data storage layer, and the data processing or analysis, data visualization. So data visualization is not exactly a tier, but once you process the data, once you analyze the data, you might want enrichment of the events that you actually processed. So data visualization, and either you do data visualization or you actually, send these analytics artifacts to the downstream applications. Not necessarily strictly visualization, but it will be convenient to put this particular layer, right, for better understanding, and it varies from business to business. Now, if you look at each of these individual tiers, right, we put a set of tools, right? Plume, Scoop, Kafka, right? In the data ingestion layer, and data storage, we have HDFS and HBase, right? And more. So in the case of unstructured, semi-structured data, we deal with, like for example, MongoDB, Cassandra, right? There are also databases, graph database, and Neo4j. And Neo4j does a lot of other things as well, right? Not just storage, but these are the some of the platforms and tools in the data storage layer. Now, next comes the data processing analytics layer. Analytics layer, most predominant one is Databricks and Spark in recent past. Spark has changed a lot considering last 5-6 years. There are two types of streamings it used to support, like D streams and structured streaming. Now we even deal, streaming as if we are dealing with SQL queries. That means continuous query processing. That is something is more prominent nowadays. And of course, you have Hive, Pig, Mahout. This is a kind of big data ecosystem. And also we have Python, right? Storm and all that. So these are the couple of tools, right? There may be a few other things also, but I thought I will put things which are more prominent. Now in data visualization, we can think of SAS, Tableau, ClickView, and of course Power BI as well, right? So these are total, tool stack most prominently we can look at. Of course, as I said earlier, there could be a few others as well, but you know, considering the space and other things, I thought more I will put a few things here. Now, when it comes to data source, it can be a web server, application server, or some kind of database or cloud environment, from where actually you ingest the data through these particular tools that you are seeing here. So this is very prominent and a very popular Azure uh, data architecture. Actually, you can actually go through this in Microsoft documents, right? This is very nicely articulated and written over there. I just refer that. That's why you can see the link also in the below. You can go to Microsoft.com docs, and you can visit Azure big data architecture. Then you will see that. So in this, what happens? It has both streaming as well as batch processing, right? We understand what is data source, we understand analytics and reporting. So essentially in between these two tiers, what exactly happening is what we are trying to predict from this particular diagram. Okay. All right. So as you see here, it supports batch processing as well as stream processing. That means whenever you do batch processing, you need additional storage because you want to accumulate these messages. We call them events, right? A message or event is a record, single record, right? It might have a timestamp and few details. One example is that when you perform some online bank transaction, right, through credit card, that could be one event. So your bank application might track these messages, and it might use some machine learning technique to predict whether it is a fraudulent transaction or it is a outlier in terms of abnormal transaction in terms of amount of purchase or so on and so forth. That's why when you make big purchase, right, like 2 lakhs 3 lakhs using your credit card, immediately you will get a call from your bank customer care. So these kind of triggers you can actually look at using the model which is already developed, right? And you actually give this as a new example to that model, and it will predict whether it is abnormal or not. So it will create a trigger. So the time scales in which you are working, like for example, batch processing means essentially you look at the time scale of few hours. Stream processing means your processing will be after every second, every few seconds, uh, every minute. For example, few seconds means so on and so forth. So this is kind of architecture we normally refer as lambda architecture. It supports both batch as well as stream processing. So when you process that, either you put in an analytical store uh, and use it, or either use directly to the downstream applications. See, two things you need to understand here. One is data at rest, data in motion. The traditional database applications where you also run analytics, right? Like you fire some queries on your table, right? Such things are data at rest because you persisted the data. The moment you persist the data into a storage mechanism, storage system, then the data is at rest. On the other hand, this kind of data uh, systems, right? Where data is continuously moving. Data is a stream. As if you have a bucket, and there is a stream of waters flowing through some river bank or so, and you are actually sitting on the bank of that river, and periodical intervals of time you are just uh, immersing your actually you're collecting water using your bucket, right? So when you collect water from a stream, water stream, there are two possibilities, right? One is that you collect volume in terms of you put a marker on the bucket saying that, okay, till this volume I will collect. Or you actually put a clock or a stopwatch and say that, okay, I will collect water till that particular time interval. Exactly similar things you do here. Either you have a window based on the number of messages that you process, or time frame, 10 minutes window, 5 minutes window, or few seconds window, and all that. So depending upon the window you are using in your use case, the complexity will vary. Uh, Batch processing is less complex compared to stream processing, right? And batch processing requires high volume for storage because you accumulate the messages till 8 hours or one day. At the end of every day, you process your messages, right? And by the way, the models that you develop based on the batch, right? They're more accurate because you have enough data to run your machine learning model to perform some analytics, right? Compared to the analytics that you perform on stream processing. But if you look at online algorithms, right, potentially you can even use stream processing as well. Okay, so essentially, uh, it boils down to complex versus simple, right, in terms of analysis. When you want to perform more complex analysis, you rely on batch processing, and if you want to perform simple analytics, like I told you, predicting a particular transaction, you already built a model and you just use this new message and try to predict or infer. So this is also called just-in-time enrichment of the events. One important thing that we need to understand about the sources of streaming data. What are the sources actually for the streaming data? So predominantly they can be classified into 4 or 5 areas, right? One is application monitoring, like when you generate a lot of log files, right? Or if you have a sensor, let us say you have a healthcare application where you put ventilators, right, for COVID patients, and you put some oxygen cylinders and all that, and continuously you need to monitor oxygen levels and health of your ventilator system then periodically that system will collect the data and it will trigger whenever there is some abnormality, right? That is some example for application monitoring. And if you look at web analytics, let us say you are visiting some online retail store, right? And you want to perform various recommendations based on the search criteria used uh, by the visitors or customers. And online advertisement is another potential area, right? Social media, for example, both one, and mobile and IoT related device data. These are the few sources for streaming applications. Now you can see in the bottom there is a orchestration component, right? So orchestration will coordinate and configure various tasks, right? People who are familiar with streaming, like Kafka or Spark, right? Uh, Especially Kafka stream, they use Zookeeper. So Zookeeper is essentially a kind of controlling and uh, coordinating system which will look at every node in the cluster in the distributed environment. Having discussed all these aspects, if you are a data architect or aspiring to be data architect, there are three important non-functional requirements one should look at. One is horizontal scalability. What is horizontal scalability? You essentially look at how do I scale my application. One is that you put more RAM, more uh, you know uh, processing speed on a single machine, or you have a distributed network. You have replica of these machines, and we are talking about horizontal scaling. That means distributed environment. That is first non-functional requirement. Second non-functional requirement, low latency. The read-write operations you want to write reasonably at good speed by comparing with the rate at which your data is coming in, right? Or data is flowing. That's why continuous querying mechanism is what we do. That means data is not at rest. We actually move our code, move program to the data, right? Where data is moving continuously. So that's the beauty of this particular thing. And in contrast with traditional database systems, so something like your Oracle database and structured query programming and things like that, where data is persisted. Once data is persisted, then only you are running some queries on top of it, right? So this is very, very interesting and important thing. Now let us look at next thing. Now, streaming analytics. Streaming analytics means that, as I explained here, you can. This is actually uh, taken from Apache Spark. This is the source, and you can always look at spark.apache.org. Right, you will get a lot of information on this. And I already explained this how the batches are getting processed. Right, they will be processed in small, short intervals of time. You accumulate the data and enrich the events. So we talked about big data. Now let us look at AML and all that. So this basically analytics tier we are talking about, and this is basically hardware behind that. That means you may be having a tool, but essentially how it works, right? So let us look at these three areas: AI, data science, and machine learning. So AI is basically kind of intelligence. It is simulation of how humans think, basically, right? So in this, you need to understand two things, general AI and narrow AI. What is narrow AI? Narrow AI focus on single task performance of the algorithm. In this case, especially, they get deteriorated due to some kind of slight perturbations that we actually see. Examples were like for example, search algorithms or chatbot applications or some kind of disease detection and things like that. That means narrowly you are mimicking our human intelligence, very narrow uh, degree. Now, on the other hand, you see general AI. General AI means we are actually looking at system which can mimic our human thinking, right? And implementation of this is slightly difficult because that it implicitly use hard-coded logic to the greater extent, and the hard-coded logic not necessarily get translated into real-time adaptive learning. So the examples like self-driving cars and all that comes under this particular thing. Now, data science, I think there's so much of buzz around the data science, and one is actually putting various skills under data scientist role. If you look at various online blogs and all that, so people are very aggressive in posting all this content. So I don't want to actually touch upon things which are already available to the greater extent, or which many of us already know. But I look at experience perspective and how that can be translated into various broad areas, right? So otherwise, if you ask, let us say, if you ask somebody, right? So what are the skills required? One can give a laundry list of skills, right? But we need to be prudent in terms of how we can categorize and what is actually needed in general, right? In general. So other one is machine learning. So data science, we have enough idea, I think. Otherwise, it is basically generating insights from the data. Core skills in data science area are connected with database, not necessarily connected with how much depth of implementing ability we have in machine learning and stuff like that, right? Now, machine learning, right? I will touch upon machine learning short while from now because there is a slide for that, I think. So now, what are the broad areas one would be interested in? Mathematics, domain expertise, storytelling, machine learning model development, data visualization. These are the broad areas. So domain is something that one will get once you get a opportunity to work in a particular domain. It is not something you get through training and all that, because it is not so difficult. At the same time, it is not so easy also, right? It is basically connected with our work experience. And storytelling means uh, generating and unearthing hidden insights from what you actually derive through your dashboards and other things, right? So if you look at artificial intelligence, it is a big set of activities that you perform, like deep learning, predictive analytics, and actually deep learning is part of your machine learning. And there is natural language processing related tasks, that is translation. It can be language translation, or it can be speech translation and things like that, and information extraction. Then speech, another area, text to speech, speech to text, and robotics, and open cv, for example, you have computer vision and applications, object detection and things like that. These are all various broad categories. The reason I just want to present these in front of you is that what are the broad categories. Suppose someone wants to learn ai, right? Broadly you can prioritize. First, machine learning is the must, right? After that, we can pick up any one of these things. Computer vision is one area we can pick up, or speech can be another area we can pick up, and NLP can be another area that we can actually look into, right? So not necessarily that one need to master all these things, but most importantly, how perfectly we have actually learned the art of using these systems. Now let us look at big picture. So we have machine learning, we have supervised learning, unsupervised learning, and reinforcement learning. Supervised learning is basically task driven, that you do some kind of task, classification task, regression task. Classification means that you have a data with features, and you want to predict, let us say, whether it will rain tomorrow or not, right? So that is one thing. And whether a particular cancer tissue is you know magnet or villain, or in terms of you want to predict whether person will repay the loan or not. So you have outcome variable which is categorical in nature. And on the other hand, you have regression where you want to predict, let's say predict the price of particular stock, right? That can be a regression problem where outcome variable we normally refer to as a continuous variable, right? So unsupervised learning, we have clustering. Essentially, you look at collective intelligence of all the data points and how similar they are with respect to one another. And associations. Associations means suppose you visit a supermarket, you look at uh, people who bought milk, they also bought bread. So essentially, you look at association, even though the items are not correlated or relevant to each other, but collectively uh, implicit relationship. Like for example, one application I would like to highlight here, one use case. Let us say you have an account, and in that account you actually gone for some training requirement, right? You train people on, let's say, Java, and you train people on, let us say, after that some DevOps tools, etc. Then if you use associations rule mining, potentially it can come up with something like that. In future, you may want to train them on Spring Boot, right? Or microservices. So that is the beauty of association rule mining. And feature exploration, that means you want to identify higher order features, right? I don't want to actually discuss in detail because our objective is to discuss overall discipline of data as such, right? Now, data science, these are the critical activities. First, you need to look at what is our goal, right? You can define that what exactly you want to achieve. Then, how much time it takes, what are the resources you need, project charter. Now, data representation, internal and external data. Is it within the system or you need to source it from outside? Something like web scraping, right? Where use tools like Beautiful Soup, etc. It scrap the content from some resources, web applications, right? Now prepare the data using data cleansing techniques, data aggregation techniques, and data transformation. Then you use visualization like correlation analysis and pair plots, etc. And you construct a machine learning model and evaluate the model and use the findings. So these are technology stack. I am purely looking at Anaconda ecosystem. Anaconda is the most popular ecosystem when it comes to machine learning models, especially when you are using coding environment. Now let us look at the most important thing, that is roles, competencies, and skills. So I broadly try to come up with a few roles, considering the traction that I see. So there are two areas broadly: data analytics, data management. Data analytics, these are the rules, right? A, a big data engineer, data scientist. Predominantly, if you look at skills, these are all competencies, right? Ability to develop solutions, data models, streams, etc. And ability to use different tools and frameworks for big data engineer. And ETL process implementation, integration of Hadoop ecosystem, and things like that. These are the skills. Java, Python, some ETL tool, extract, transform, load tools like Talent, etc. Some visualization tool, MongoDB, Hadoop, right? And there is Airflow also. This is a kind of ML ops related stuff. And one cloud environment one should be familiar with, whether it is AWS or Azure or GCP or Databricks or whatever. Now, data scientist, I already explained what the role, and you need to know few skills like Python, SQL, machine learning, one visualization tool, etc. In that last, I'll summarize all the tools, right, as a roadmap. Now, data analytics, you have a support engineer and visualization expert. The a support engineer is focusing on more deployment and CI/CD, continuous integration, continuous delivery aspects. Right? Data analytics visualization is mainly to do with maps, charts, and performing some kind of descriptive analytics. Correct? And these are the some of the skills. One of the most important skill is uh, storytelling. Storytelling means unearthing hidden uh, insights. So data management aspect, ETL developer, the key skills are Java, Talent, Cassandra, data warehousing frameworks, something like relational online analytical processing, right? Multi-dimensional online analytical processing and concepts like that. Data management developer, Informatica, few ETL tools and all that. So these are based on whatever I see and also some inputs that we normally look at job descriptions, right, in various sites. Now let's look at roadmap. So what exactly one can look at? You can just look at the core workloads, right? One database area, ETL area, streaming, analytics, visualization, and coding. Considering these areas, we can pick up a couple of tools and platforms in each of these things. I will just give 1 second, you can note down. Right, so let me do the next thing. Next, finally, last one but not the least one, coding. How exactly we can learn these tools, right? First and foremost thing is we should learn a programming language the way it has to be learned. So there is a concept called thinking programming, right? So there are broadly three approaches normally one look at in thinking programming. Program language oriented thinking, programming oriented thinking, programming independent thinking. So if you want to be successful in this area, right, we need to be programming independent thinking. I will give an example. This is a classic paper published in 2000 that is on cognitive process of students dealing with data structures, right? So you look at three ways of thinking. One is that if you take simple array, right? You look at, in my language, array index is 0. But the best way to understand is that array has list of elements with subscript. That's how we need to look at this programming language oriented thinking. On the next level, right, programming oriented thinking. So you have operations that are defined on the particular language, insert, append, and all that, right? Now, most important thing we need to be at is programming independent thinking. So that is where many people struggle in coding in Python, because in Python you have list comprehension, lambda expressions. These are all connected with mathematics. So you should be good in defining certain operations in mathematics. Then understanding these powerful constructs will be very, very easy. So I will show one important thing also. So what are the areas we should focus on in Python when it comes to? So I actually published a paper in IEEE conference that is programming in a digital world. Okay, you can actually just look at this. So this is the publication, Programming Curriculum Pedagogy in Digital World, right? So we can get it. It's not a, sorry. Let me go to the last slide. Yeah. So these are the key important things that focus in Python. Now I will show you some use case. These are simple, sample code snippets. We keep talking about data structures and algorithms, right? What exactly one should learn? This is a real-time use case that I actually worked on. I cannot share the code and other details. Everything is, these are all dummy, right? So this is a clear example what one should learn and how one should code. So you need to use functions wherever possible. That's the first one example, right? Now I have a function here, concatenate skills, where I have different skill categories. One is project skill, something is employee skills, current skills, and all that, which are used in the project, right? So I need to concatenate all the values in that particular multiple columns. That's why I have a skill column list. Then I want to create a new column. PYC is my data frame, and the new column I am actually processing various columns on the right hand side. You can see that, right? For all the columns in the column list in the data frame, I am applying lambda expression, right? So I am concatenating them with dollar each skill, right? And I'm also checking whether that particular value is null or not, because sometimes in the column we may have null values, so that may actually give wrong results. So this is a beautiful example of your mathematical expression, right? It is like f of x is equal to x plus c for all c belongs to list. Okay. Now, similarly, you may want to match, like for example, what is the open requirement in the project and the people who are available for deployment, and we look at the band. What is the band required for the project, and band of the people who are actually looking for project. So you can create a dictionary. Let us suppose there are some dummy bands A1, A2 up to B5. Now you create a band dictionary, right? So you create a band gap. That means that whether it is a right fit or not for that particular fulfillment. So you just use dictionary. Such a powerful operation you can do, right, using dictionary. Similarly, you may want to match the skills. So you construct you populate the skills required for the project in a set data structure, and you do the intersection operation on the set of skills required for the project and the set of skills that person is having, and based on the matching percentage you can take a recommendation, right? And you can create some dummy IDs like this, and you can encode the skills also using some lambda express using list dictionary comprehension. This is, you can see that, right? So lambda expressions, dictionary comprehensions, list comprehensions, functions, these are the dictionaries. These are the main things that one should learn. Okay. Thank you so much. Now I am open for Q&A. Any questions we can take up now? Let me see. Just give me a minute. I will look at. Questions.
Hello, sir.
Yeah.
Yes, sir. Can we close, sir? Then we got some questions.
No, I'm checking that. So far, I could not find the form I am seeing. Form responses I'm looking at. I could not find any question so far. So,
Fine, sir. Then you can give a conclude remarks and we can close, sir.
so thanks all. I sincerely thank IT Madras and NPTEL for giving me this opportunity. Thank you so much. Thank you.